You might find it helpful to look at the graph of our cafe example. So over here on the left, you can see that we have written the three different functions that we need to work with. This first function in red, this is our cost function. We know that we have the fixed daily cost of $200, and we're going to spend an extra 25 cents per cup. Next, we have the revenue function, where we are making 95 cents off of each cup of coffee. Lastly, we have our profit function. And our profit function combines the cost and the revenue function by subtracting the revenue function minus the cost function. We need to go in this order because we need this fixed daily cost right here to be negative, and we need our actual revenues for the day to be positive, the money that is actually coming in from the selling of the cup of coffee. We need to see that positive slope in all three of these graphs because we need to understand that all three of them need to be increasing. As we make and sell more cups of coffee, we have our expenses go up, we have our revenues go up, and therefore we have our profits go up. What I really wanted to look at in this graph, though, was the relationship between the cost and the revenue graph and what that means for the profit. So if our cost is starting at $200 of a fixed cost for the day, and we're increasing by 25 cents every time we make a cup of coffee, we will eventually reach the point where our revenue is going to surpass our costs. It may not happen for a while, but in this case, and we can see by looking at the intersection of the two lines, it happens at about 285, 286 cups of coffee sold. Now, that's not ideal. You'd love to have an individual location where that happened, but we don't have that here. But look at the effect that that one point has down here on the profit graph. On the profit graph, we're not looking for an intersection. We are looking at this, and actually this green line intersects both the blue and the red. It intersects the red over here on the right, way up in the positives, and it intersects the blue way down here in the negatives. But it doesn't happen where anything interesting is occurring in either of the graphs. What we're looking for here is what's happening at this 285 number. And if we scan along our green graph, we'll see that at that same 285, 286 number, that's where we realize a profit of 0. This is the location that we call our break-even point. This is the point where our graph goes from, or our company goes from losing money to making money. Now, if you want to subdivide this graph, it probably wouldn't be a bad idea to think about it in a couple of different ways. To the left of that break-even point, so here's our break-even amount, right here and right here. To the left of that break-even amount, we see that our cost line is above our revenue line, and we see our profits are underneath the x-axis. They are less than 0. All of this over here is where we are still losing money. We have not made back our money for the day. Once we cross over that break-even point, the profits go into the positives, the cost line goes below the revenue line, and this is where we're actually experiencing profit. So we want to design these functions, and anybody who's designing a business for that matter, you want to design these so that this point, this break-even point, is actually in an attainable location. Is it realistic to sell 285 cups of coffee a day? You stay open for 8 hours, that's about 30, 35 cups an hour. You have to decide if you think that's reasonable for you. But this kind of analysis can make it very obvious if you use the revenue and the cost graph where that break-even point is, or even if you just use the profit graph.